Institute President, Mr. Kemal Topalömer, are with us today. With their valuable experiences, we welcome them today. To briefly have this introduction, I will be giving the word to them. Of course, in recent times, as you know, we can see wars, conflicts remind us and give us important messages. Honestly, in relation to our panel's topic, I also wish to touch upon the changes happening on the field with 4 to 5 headlines I have in mind, which I will be sharing with you. In recent times, we see the characteristics of war change with pinpoint targeting systems evaluation. In recent times, of course, compared to previous eras, we have intense firepower, which was prevalent. In recent times, in addition to the prevalence, we have pinpoint accuracy, low cost, high impact principle take precedent. Of course, long range ammunition, cruise missiles, and smart munitions are now not the traditional method we know, where it belongs to the powers that be, but now middle-scale nations are also now stockpiling them. We see this in the Russian-Ukrainian war, especially HIMARS with their long-range pinpoint logistics centers targeted, which had an important evaluation done, which heavily impacted the tempo of conflict. Second topic is drones and munition integrations with their integrated systems making their appearance. We see unmanned vehicles take precedent, not just for scouting or observations, but also for assaults as an assault strike platform. We have kamikaze drones, their related munitions, and swarm drones with low costs and high operational capabilities. Now we have missile system integrated network-based structures also show their face on the stage. And one of the most beautiful integration examples, as you know, we have seen in the Nagorno-Karabakh conflict, which our panelists will be also touching on. We see classic armed forces and air forces also take part with our unmanned systems, and the race we have between the missile technologies and air defense systems. These technologies evolve, and especially we see defense systems and the technologies utilized also change in the same speed. Hypersonic threats, low altitude munitions, and we see capacity strikes challenge the current architecture of industries. Therefore, multi-layered air defense and also sustainability and cost-efficient air defense concept has also become a strategic importance. And again, in Iran-Israel conflict, we see this. We see multi-layered defense systems and missile stockpiles effectively utilized against drone strikes. 4. AI, data and decision-making speed. AI is being discussed, yes. These technologies and their impact on the field is a factor that changes the nature of war. Modern munition systems no longer are restricted to carry systems, but also sensory and initiative systems. AI recognition of targets, autonomous targeting, and real-time data shapes the fundamentals of missile technologies of the future, which we have seen in Gaza. Real-time targeting, data fusion, and sensor-supported strikes were heavily used and criticized. It's not a technological structure, but also we can say as an approach, the strategic importance is something I also wish to touch upon. Recent conflicts have shown that external reliance in times of critical decision making is a risk. Therefore, nations are not just go for platforms or systems, but also engines, warheads, and other critical subsystems and technologies using their domestic capabilities. Defense technologies, sustainability, and independence have become crucial, not just for main components, but also for subcomponents to increase capabilities. We've seen this in Russia-Ukraine and US-Israel-Iran conflict, where we see electronic components become a risk factor in times of conflict. This was my introduction. Without further ado, I give the word to our panelists. We have about an hour and a half, so we'll go for 2 rounds of talks, and we will be giving 10 minutes per speaker. Maybe round 2 could go down to 8 minutes. We'll briefly touch upon their history before giving them the word, and if we have the time, we will have perhaps a 10 to 15 minutes of Q&A. For their informative and wonderful panel, I have my hopes up. I give the word to Murat İkinci, the Roketsan. But before that, let's have their brief introduction. Mr. İkinci is computer engineering graduate of Bilkent, 96. In 98, has master's and graduated and started working in faculty executive MBA in Bilkent in 2010. Between 96 and 99, in Bilkent, he has been a researcher. In 97, has become a software engineer in Havelsan, and at the end of 98, has been working there. In 2000, STM AŞ has been his new place of work, has become the software manager and defense project director. And throughout his work, has been working with autonomous systems, control systems, and communication systems, completing many high-level projects. As of 2013, from STM naval programs, defense supply, consultancy, and certification for flight compliance, has been working on consultancy and engineering. And throughout his duties, he has been contributing to Turkish defense industry, one of the biggest export projects, Pakistan Naval Transfer and Milia National Corvette projects, has been some of his portfolio, and in 2018 has become a general manager. After that, as of 2020, July 1st, has become the general manager of Roketsan ever since. Aside from Roketsan, he's also in the board of directors of Saha, TÜBİTAK, and TÜBİTAK SAGE. Has high level of English and also is a father of 2. We give the word to him with this question. As you know, Nagorno-Karabakh and also conflicts such as Gaza and what's happening in Iran, we always have seen that on the field there has been noble changes. In Karabakh, for example, we have seen drone munitions take prevalence, but in Russia, Ukraine, we see drone and anti-drone systems take precedent. But in Iran conflict, long-range drones, pinpoint targeting, and hypersonic systems were heavily utilized. In this regard, in terms of munition technologies and missile systems, what radical changes have been brought up? Thank you. First and foremost, thank you all for joining here today. Of course, munition systems, by munitions we mean offense and defense systems. They rapidly change, rapidly update, and has to adapt to all technologies at a pace. In the past, munitions, of course, had the fundamental expectation of, rather than sensibilities, but the growth. heavy destruction and bigger warheads were preferred. The biggest concept of World War II and since was to develop the largest impact area. But then, expensive but high sensitive, high capable, high range systems have taken shape. We see cruise missiles, ballistic missiles, of course, have been prevalent, and air defense systems that would prevent the enemies. But in recent times, in these conflicts, we have seen radical changes happen. In Karabakh, we've seen this in Ukraine, in Syria, and later on, Iran. The Israel-Iran conflict have shown us that the munitions technologies have substantially, fundamentally, are undergoing change. Before Karabakh, the defense industries, dominant nations mostly invested in high technologies, having multiple features, settings, heavy and expensive systems. But especially after Ukraine, the transition has switched this to rapid production, pinpoint accuracy, sensitive but also cost-efficient systems. The Iran conflict have become a counterpoint to this, especially between Israel and Iran. We see high-cost systems take the stage, but the biggest problem there was that the systems there would get depleted fast, slow down fast. The defensive capabilities, the production capabilities would be hindered, where we see production is slow but consumption is fast, and the replacement of munitions would take long times, where we see the governments produce them and also acknowledge the hindrances. The air defense systems at this moment would be replaced entirely in like 3 to 4 years, as we can see in the publications and public declarations. When we talk about munition technologies, we cannot just put them all in the same basket. It's a combination of things. This combination includes rapid, cost-efficient products, but also high technologies. At the moment, what we are also considered about heavy impact technologies such as hypersonics, AI-based, high materials, especially in terms of navigation, the precision, intense systems integration are also a priority. In Karabakh, we have seen the massive electronic warfare put in practice, where we see electronic systems, where we see systems such as GPS were not as reliable as we thought. Our high technology systems would be facing this, not just GPS scrambling, but also data link hindrances, communications regarding problems. In fact, the navigation systems completely fooled by fake data, and therefore impacting the munitions performance heavily, and with it, more problems. So, what we are spending our effort the most on is resilience against electronic warfare. GPS or locationing systems problems hindered or perhaps have meter-based targeting or deep strike capabilities of long-range systems and their effective use on the battlefield. Hypersonic technologies combined with what I just mentioned, we see in air defense systems become a serious threat, and they are most problematic with such missile systems. Of course, developing technologies also require defense from such technologies, and we have to increase our own capacities in this regard. Air defense systems, of course, have, the typical classic AI scenarios. And when we look into those, we see radar, we look into a controller, a monitor, an observer of systems, human-based. But they have to be so rapid in their response that we have come to a point where the decision-making mechanism is hindered by human interference. But the threat analysis, threat prioritization, the impact of attack, potential of preventing it, the touch point, and everything else now can be left to AI and computer to calculate, where the command systems are integrated into it for a holistic infrastructure of air defense systems. This is one such concept. We see modern technologies are not individual, but now holistic, with AI-based support in between, with sensors aiding at every step, with a command hierarchic structure. An Iron Dome of air defense, what we call an Iron Dome is our air defense system, is based on this. Munitions and defense. Offense and defense technologies always compete. This competition will never end. I made the best. I no longer need to have an AA system. It's the nirvana. Perfect defense is something you cannot say. You can have sensor infrastructures and data technologies implemented, but offense systems will be overlapping your defense systems. Changes will happen rapidly. Therefore, in our sense, we have to have our own systems and their capabilities increased with new technologies, and also have air defense Iron Dome developed and its infrastructure enforced. What we see now is this, but for the future, what we can say for the future, we have to be prepared. Targeting technologies and fields are being invested, of course. High power laser technologies will be crucial in air defense for the future. But that's what we presume. Also, high power microwave systems for air defense will be integrated. Hypersonic is now being outdated by newer systems. Atmospheric space system supplemented control systems, deeper penetration capabilities, deeper effectiveness capabilities in munitions, and more. All of these show that there is a future that we have to be considerate of. Also, at the same time, we have to decrease the costs, produce them faster, perhaps have less capabilities, but have multifaceted features, and neutralize threats that also have more features on the way. There's a multifaceted family of munitions, and their technologies change. Instead of intensifying focus on a single one, we should be focusing and utilizing each of their respective advantages. Thank you.
Çok güzel. Thank you very much, Mr. Ikinci. Of course, coordination is extremely important, because what we see is in Ukraine-Russia war, 155 millimeters ammunitions, maybe they could be thought of as an old technology, but this is the first time they have been used so widely. They are cost effective. Maybe they are less capable, but when you combine them with higher technologies, being ready for all that is extremely important. And I would like to thank Mr. Ekinci for all that he has added about that. Now, General Manager of MKE, Mr. Ilhami Keleş, will be speaking next. And before that, I will talk about his past. In '62, he has been born in Çorum, and in '78, graduated from military academy. After controlling many different areas. He has been in air defense as an artillerist, and he has been working with the leadership of Aselsan and in a consortium that includes also TÜBİTAK, which has produced Herix, and the inventory systems and development of the advanced versions has been controlled by them. And again, in Helix, the instead of using Sentinel radars from the US, they have used our own local product. In 99, in Gazi University, they have completed their masters in economy, and in 2023, they have received their military education and in 2013 he has retired from active duty as a commander. In 2015, Saha Istanbul established, and he has been the founding general secretary. He has been among the leaders of the industry. Saha Istanbul started with 27 members and has reached everybody that you can see right here, and it has become the biggest group for the defense industry, and also establishment of space industry, and Tasaksan Milteksan has been established with his efforts as well. And in 2022, Saha Expo has been participated by 38 different countries, 957 firms, and more about 1,000 delegations from official governments, and more than 900 private companies representatives have been with us. And in 2026, Saha MBA program has been established with his leadership. For the success of national technology development, he has been working tirelessly, and finally he has taken his position in MKE as a general manager. So let me start with his first round question, Mr. Kelesh. As machine and chemistry industry is what you are working on now, so your institution has centuries of experience, and it is one of the biggest supplier for the defense industry. And of course, because we have high sensitivity and fragile ammunition, and as MKA, which strategical areas do you focus on, and what kind of capabilities do you focus to develop? Go ahead, sir. Thank you very much, moderator. Now, first of all, of course, with the developing conditions currently, we have a separate environment in terms of warfare. Since the Second World War, technology has developed a lot. Within the scope of this development, countries have been developing new systems constantly, and they have invested a lot of energy towards that, and they are constantly improving and developing more and more complex systems. But for the first time, we have seen two conventional militaries fighting each other. Since World War II until Ukraine war, we only had paramilitary wars or proxy wars or smaller regional conflicts were the case, but now this is the reality. Now, as this has been the case, and area that we are in is we see in the Ukraine-Russia war there are very sophisticated and very expensive systems that have been developed, but even a giant like Russia is running out of them in 2 months, and Ukraine the same as well. So because of that, sustainability of war and keeping war going requires conventional systems like regular artilleries. We can see that. So you need to analyze something very well. And the second one is, of course, production requirements of these systems. And of course, Mr. Murat talked about that as well. Mr. Murat talked a lot about everything. He talked about everything. So I'm going to have to repeat what he said. So rail metal income has increased by 47%, and MKE is not just that. Rheinmetall is also selling armored vehicles, and MKE has grown 38%, and it includes ammunition. So these are not routine growths, these are exponential growths. So there is a reality like this. And the third signifier is these weapon systems are not a parameter, they are actually ammunition is a strategical point for all of us. Of course, while doing all this analysis, we also experience some new developments from Syria to Iran. Of course, Ukraine, Gaza, Iran, and Karabakh, all that it shows that the kamikaze systems are being used a lot more, and classical ammunitions and drones, they are becoming a very important paradigm. And to be able to react to that, we have to reshape our own investment. And I want to tell to you about this specific number. In 89, when Berlin Wall has been felled, when they lost enemy, they lowered their inventory ready for 45 days down to 12 days. So they lowered the numbers in their military armies as well. We would have different units in every city in Turkey, throughout Anatolia. They are getting lowered in number from NATO. So in terms of army units, we are lowering the numbers. In addition to that, other numbers are going down, and inventory amount is going down as well. So because of this, every country is using end of life ammunition and inventory in their systems and trials. And for example, Turkish army had a war against terror, for example. Even though that's a localized conflict, the ammunition has been used so that they can keep it live. And 155 millimeters ammunition has been used by the Turkish army for 18 years, and they have never ordered this for the last 18 years. When they all started, they, their capacity to produce those ammunitions were only 4,000. Now we are talking about millions. The backlog of MKA is about $8.5 billion. So the new conflict is creating more demand for conventional ammunition. So to clearly state the situation, I wanted to share that development. It is unique. Again, in Syria, we have observed a lot, and for the first time, Turkish armed forces have used drones and humans integrated in battle. For the first time, they used drones, automated drones between themselves, and they used military personnel in the same war. They combined them. The trust in drones is increasing thanks to that. It is an important milestone. And also in Karabakh, they also used drones in that conflict as well. Both Azerbaijan and Armenia did not have air superiority. So drones have decided that. So what they did to maximize the amount of drones that they used have actually achieved the capability to break their systems of the other side, of course, and it was extremely important in the battle. And as we said, there is an asymmetrical result in battle now. 300 or 500 million dollars of ammunition or tanks which are costing about 3 to 5 million dollars. So you can destroy that with just a drone, which is very cheap. So the success in that area is of course shining and people are focusing on that. But Turkey is extremely lucky because our drones, Baykar TB2s, have been used in Ukraine and before that in Libya, in Syria, then Libya, then in Karabakh, then in, of course, Ukraine. So until that point, the world did not focus on that a lot. But in the beginning, in Ukraine war, they used it to dominate air superiority, and it was very attention grabbing. Everybody focused on that. And in drone technologies, Turkey has taken very important steps and developed a lot. But at the moment that's the moment when people, international community realize that, and you see in this event as well, we are openly showing all of our capabilities and we are giving services and products to our allies. And another thing that we should focus on is, of course, kamikaze automated drones in the sea. You know, there are specific ones which are only going on the surface. So this is a new kind of ammunition actually. It is one-time use. So they have received a lot of great results. In a flagship in Russia has been destroyed by kamikaze drones, which was transferred throughout the surface of the water. And in terms of fleet, even though Ukraine did not have any advantage, Ukraine was able to keep Russia out of Crimea, and of course mines are effective on that as well. As MKE, what the analysis that we are doing shows that we believe 2 years ago we decided to produce effective, simple, and cheap, cost-effective solutions. As Mr. Murad also said, both in terms of offense and defense, we have to take precautions in that sense, and we established our strategy like that. Should I? I'm seeing you are moving a little bit. All right, I will finalize. Mr. Keresh, thank you very much. If you like, we can continue in the second tour. We have limited time. In that sense, I believe it is very important to hear your approach. We have a lot of activities that we are joining in NATO, and your approach is, of course, selected and approved since the Ukraine war, maybe in the Cold War, after Cold War, after big sophisticated systems that were popular. Now, effective, simple, and cost-effective, impactful systems are being focused on right now, and we can see these cost-effective solutions are very impactful and creating great results. So I think that's a great roadmap for us, because there are many organizations like NATO that are focusing on that side and going forward on that. And thank you very much for the emphasis that you put on that system. Now let me introduce Kemal Topolu. He has been born in '86 in Kilis, and in 2010 he has graduated from political science in Medu University, and again he has completed the industrial engineering education as a master's degree in Medu again, and he has been an expert, a professional expert in the Ministry of Technology and Industry, and he also has taken roles in many different roles in presidential departments. He has also worked on quality and strategical management departments as the leader, and also has worked on commercial applications. Throughout his work, he also has worked on NATO committees, and since 5th of September, he is the Board of Director and Institute Manager of TÜBİTAK SAGE initiative. Now, very quickly, I would ask Mr. Kemal Topalomer, in 2025, Pakistan and India air conflict, and also the situation with F-35s, and we see that decentralized management is extremely important, and what kind of operational roles are located for the product that are being developed in TÜBİTAK now. Thank you very much, sir, esteemed general directors and panelists. First of all, I would like to greet you all with respect, and as you also said, in 2025, India-Pakistan air conflict that happened in 2025, and also the US-Iran conflict that we are seeing, that the air domination, even though has been lost, they are saying that they have prevented F-35. So we can see missiles are going to be it's not going to be possible for missiles to be the future of air combat. Platforms and missiles are not the focus now, they are just paradigms.
We see data centers take precedent. Now they are at the center. And we see that earlier data production, earlier data processing, decision making, and with its digital nerve outputs, have platforms, the missiles activated in response, has achieved asymmetrical success. India, Pakistan also has shown that both nations had a relatively similar fleet capability and munitions, but Pakistan has pulled a magic trick, as it were. And we see that this new concept is the cause. This rapid deployment and movement could be discussed as the future systems, but we see from discussions to reality is a short pipeline, and we see the technologies also give chase. These network-based attacks now don't look at munitions of fire and forget, but fire and control. And aside from that, we see 5-layer structures of these network structures. We see identification, crucial, of course. We see different parameters involved: satellites, drones, scout drones, VSF IRSD, the latest infrared radars, sensors, the ground radar systems, and also the first sensor. Even people are also actively used on the field. We know this because in the Ukrainian conflict, the low cruise missiles were not detected by radars. That's what the Ukrainian system was. And citizens could see the missiles by their naked eye and report that to a center. It starts from the person all the way to the most complex sensors. Threat identification is the first step. Later that, this identified data's security, encryption, and transferred to a command center, a center in its entirety, is another necessity. We have MTDL, the data linking, where we have our national domestic communication networks as such in our countries, and other countries also have their systems. We see existing libraries match immediately where the threat is identified and classified, leading into stage 3, field or rapidly deployable platforms, systems, targeting, deciding on which one to use on what threat. Where we see people decision-making speed is not enough. We see this in the Iran-Israel conflict. We see an American company take this duty, actively work on it, change this to a manifest. We witnessed that AI take a crucial role. Rapid data processing and decision making. And then it comes to munitions and platforms. Munitions, of course, are not the typical anymore. As our managers and directors have said, after certain stages of war, well, cheaper munitions are a necessity, but sophistication could not be let up. Therefore, there's a need for both. We see smart missile systems rise in importance. Of course, as we've said before, it's not fire and forget anymore. Fire and control is the new precedent. We see data constantly flow into the missile, even after firing. Or let's say if the threat is eliminated, the mission is concluded. We see missiles also get eliminated. We see platforms see the missiles become the source of data for centers in the future. This network-centric approach gains meaning with this. It's also based on missiles, evaluation, post-firing, range, especially in air. We see 200 kilometers and more for air missiles. Have we hit? Is the target struck or not? Should I fire another missile? And such questions are answered by data provided by the shot missile. Of course, damage assessment, arrangement success, and such smart missiles work in tandem with pilots and platforms. In the future then, it's called distributed keychains in English, where we see the network-centric approaches of such chains implemented on the fields. We have developed, as an example, liquid fuel-based Gökhan missiles, air-to-air, with its features identified. That is to say, in 2025, we did a first Kızıl Elma unmanned platform had human-based F-16s in their sortie, and air-to-air missile Gökdağ, Aselsan, Asera supplemented could eliminate a target. Kızıl Elma, IRSD, and other infrared systems are also supplemented as sensors. We see planes take flight without RF, and if data is provided beforehand, they can take air without any RF and identify targets and conduct operations. And with a missile that does not have RF, based on data, we can have what we call silent engagement, where the rival forces are not aware because of no signals being emitted. Such capabilities are being developed. Air-to-air missile concepts that we're developing, as I've said before, can change targets after firing, or can have manned or unmanned control switch mid-air, or retarget by radar data in real time, or cancel fire. Such features are being asserted for our systems. And in movement types, we see 5 generation of threat where we see manned and unmanned systems combine. We see settlements take charge. We see not just kinetic or just combat munition or warheads, but MCOR and electronic warfare also take the stage on the field. And such intense systems, swarm systems, AI data systems, with AI capabilities, we see swarm technologies rapidly deploy onto the field with success. And in the future, these will be the topics of discussion. Our country, of course, will work. And as TÜBİTAK SAGE, we will be also working on it with our new generation missiles, cruise missiles. Last year, we have qualified the Sonje missile. We see intermittent data pipeline to and fro can make it change targets, go for silent cruise, and more. Our work is being conducted still. To summarize, in the future, a nation may have 5th generation jets, meteor missiles, and other missiles or similar concepts, yes, cannot be simply the tag that says this country is strong and successful. Capabilities, what technology brings, will be impacting all these systems, harmonize them in a digital system, establish a digital defense nervous system, and give an asymmetric advantage. And we are happy to take part in our nation's development in these regards. Thank you. Thank you, Mr. Kemal. What you have described is can be summarized that 1, network-based talent. You have different assets, different values, and have them integrated around the network, have them total to a higher capacity. Of course, fire and control concept is also crucial, where you have intensified work on it, air-to-air conflict. It's a crucial capability that is in the development. So thank you for your work. For round 2, then. But with this, in round 2, I want to pick up the pace. We are running low on time. Therefore, if it's appropriate, I will be giving us all 5 minutes individually. Murat İkinci's round 2 and question 2. In recent times, we see in the civilian sector, we see technology develop with AI, quantum navigation, production technologies, and more. And also in civilian technologies, we see rapid changes also take part. When it comes to munitions and missile systems, how was the impact? Future brings change. Change brings the future. So, what is the current situation? Of course, I want to touch upon that first. Munitions and defense technologies are becoming integrated. not just AI or quantum technologies or just hypersonic technologies. None of them are exclusive. Rapid production, 3D printing, and also new generation sensor systems, or what we prioritize or focus, navigation technologies. All of these are harmonized in this munition and defense ecosystem, I believe, in the future. Civilian technology and defense technologies, of course, civilians would be following from the back, but now from 90s onward, communication and production technologies have been the order makers, the decision makers of the military sectors. Of course, technologies such as communication in our defense sector also got impacted for it. As it were, it will be. Thank you. Thank you, İkinci. Now to Mr. Ilhami and his second question. Of course, existing production of munitions and rocket systems are not just to sate our needs, but also develop the national defense ecosystem. With increasing demand internally and foreign, your current production capacity and portfolio of products also need to meet the demand. What is your current ratio of meeting the demand? And also, could you talk about your future investment and projects? Of course. In here, we have two things to touch upon, crucial. One is the portfolio, that is to say, facing new threats and the demand for new defense, and also new offense for new defense. And MKE have also brought this upon itself and focuses its efforts on this. There's also investment, obviously. In this regard, in our new product portfolios, we have, as an example, a new threat has, perhaps as the panel also had discussed with other speakers, we have drones, unmanned threats, scatter munitions, and more. So as a precaution, we have Tolga close-range air defense systems had been developed. And of course, our development advantage was that we are a company that knows how to build the weapons and the munitions. These two know-hows fed into each other, and Tolga air defense systems were established because of this. We have radars, soft lock skills, and hard kill strike capabilities layering into an integrated system with its integration into a command center. Now, in the future, we also have shown in this expo, like we have Ladar, as Murat also mentioned, the importance of laser technologies. Lasers in air defense are becoming a key component. Low altitude air defense missiles, especially in particular against drones, Infile 17 missile systems were also activated. We also, we couldn't make it here, but we also have microwave air defense systems. After FS trainings, it will be ongoing more further training and R&D. And also we have interceptors integrated into Tolga systems that is being developed, all against air threats. And of course, neutralizing threats as our industry's reaction. In terms of Ukrainian conflict, we learned our lessons, as we mentioned. The concept of swarm, and we have developed piranhas, kamikaze drone systems to counter them, which are being in our inventory now. It is also in naval testing too. Similarly, with I don't want to prolong it more, we have precautions always in the pipeline. In investment side, yes, one important thing about this panel is the scalability to have a high production capability. And in turn, we have $1.5 billion, the most comprehensive investment plan of its history. Hopefully, in our last quarter of this year, they will be actual physical finalized investments. So in 2027, with our new capacity and portfolio, MKE will have its production ongoing. Of course, existing facilities aside, we have new facilities, one in Samsun, one in Kırşehir. And also, we have R&D centers now within universities in our capabilities, of course. We have our investments ongoing. Thank you. Mr. Kelesh, thank you for your answer. And I give the word to Mr. Kemal again for his second question. You previously had mentioned air-to-air conflict. Air-to-air, of course, relies on air-to-air munitions. In this regard, TÜBİTAK SAGE has Gökhan project, as you had mentioned. In terms of technology, the transition is happening. This experience, when it comes to hypersonic missile roadmap of Turkey, is a milestone. Our question is about TÜBİTAK's work in this field. Gökhan project is something we do with Ministry of National Defense, liquid fuel nitrojets, built in 2 blocks. Gökhan projects, of course, has a precedent. One country cannot just go for ramjet technologies. Ramjet becomes a product only with 3 countries. And we are one of those. And our Göktuğ and Bozdağ were some of our projects, initial projects in 2022. Our experience gained from that 2012 projects developed into 2018 ramjet liquid fuel projects. And with their experiences, we have developed into SAGE's belief of developing such missile systems, and we agreed the contract, signed the contract in 2021. Ramjet is our most crucial technology because the range, the warhead, the other supplementary parts in Göktuğ and Bozdağ 2 had been resolved. Therefore, Gökhan project is around Mach 4, a ramjet impact, crucial with its kinetic energy held consistently upon reaching the target, would be targeting no escape zone, and despite the maneuverability of the plane, achieving the strike. This missile system is based on our experiences compared to Göktuğ and Bozdağ in terms of material, coating, application layering, titaniums, Incoterms, and more. This culmination of knowledge hopefully will later evolve further into hypersonic missiles. Of course, before hypersonic, I want to define what is it. International media sometimes misinterprets it. Hypersonic speed, rocket, and missile is something different compared to a hypersonic missile. To call it a hypersonic missile, you have 3 criteria. 1, keep it within atmosphere. 2, maneuver capabilities. To have a ballistic projectile that is different from the typical, and also have a speed achieved with munitions loaded. That's how you can have a hypersonic missile. After ramjet, of course, our roadmap leads us into hopefully scramjets, where we have initial studies conducted thanks to Gökhan, but it is a challenge. It is something, I mean, from solid fuel to liquid fuel, the transition into hypersonic is tough. Scramjet has to be designed, its air capabilities, internal combustion has to be designed with its chambers. At such speeds, you have to control the aerodynamics, the plasma, high drag, high turbulence are some of the problems it faces. You need CFD analysis, high computer processing power to analyze them. Again, material capability needs to be developed. Carbon-based structures, ceramic-based structures, other supplementary materials have to be utilized the best, because in the missile we're talking about 1,000 degrees of internal heat. Think of the external yourselves. We also have the GPS, INS, and other electronic components that need to be isolated from this heat too. We also have identification and targeting systems also have difficulties. You have to have warhead adaptability with IF and IRs and also visual imaging, and all of them supplemented with the warhead you have. And what's also crucial is that after designing it, you need to test it. It's critical to do so. In this regard, we have high capabilities. We have our infrastructure in cruise missiles or air-to-air missiles. We have our infrastructure developing and testing for such missiles. Skill investment is, of course, always ongoing, not just for our country. We have one of the exclusive wind tunnels built in our country, in Sage. We have subsonic, supersonic, 0.2, all the way to 4 Mach 4 speeds to have 1.5 meter range testing, not just for Sage, but also serving the entire sector with this tunnel. Hypersonic tunnels are also is a need on the horizon. After these test tunnels are developed, with this experience, we also plan to achieve hypersonic testing environments, hopefully contributing our country's defense industry and become a flagship country, one of the very few when it comes to such sectors. Thank you, Mr. Topal Ömer, for sharing your knowledge. I have 3 keynote speakers to thank to, and I'd like to thank them for their presentation. If we were to summarize it in 3 sentences before the Q&A.
Birincisi sofistike ve
First of all, of course, sophisticated and conventional techniques and their usage and combination. Effective, impactful, simple, and cost-effective is Mr. Ilhami has, and manage with fire is what I can say for Mr. Kemal's approach. And if I have the right to add a little, of course, high-scale production. These 3 subjects are going to be extremely important for the technologies in the future. Hopefully they will be taking us forward. Very quickly, maybe 1 or 2 sentences, if we have the time. I want to get some questions. If you have any questions, go ahead. As far as I can see online, in the defense industry, we are reaching the top spots with our R&D. Can you also tell me who are you asking for? I have a, it could be Mr. Murat or it could be Mr. Ilhami. We can see recently there have been some ships they have been shot, and guided missiles have been used for that in Black Sea or for aircraft carriers. So the most developed weapon systems are just for the Navy, both first in logistics or bigger attack ships, for example. I believe we should be adding new missile technologies into the ships in the Navy, because a lot of retired generals, for example, analyze the situation that it is going to get worse. So Gatling guns or rockets, missiles, because Gatling guns actually are great against drones because they can overwhelm them. 30mm artillery, for example, or Gatling guns are in one launcher, and they can send 9,000 bullets And we did those as well. I see it online. We have the best examples of that. So at first for logistics in, of course, should we use those supply ships for supply ships? Is that the question? Are you done with the question? Yes. Okay, now what I can say is within those we have 20 millimeter caliber, so we have this can shoot 1600 ammunition, and we have installed 3 double barreled ones, and they are in testing right now. It's like Tolga, it has its own radar system. So per minute, each one can fire away 3600. So it can be used against kamikaze drones. So it's a self-defense system against drones. These are being added, and it's in Marmaris, and it's being tested right now. Another one is phalanx. For phalanx, the disadvantage for that is you can't use those against specific ones, but as you said, it could work as a defense system. So both for phalanx and additional 20 millimeter gun systems that we are adding. So we adapted Tolga's management and the systems on top of that. So after the testing is completed, we will also give those against pirating to civilian ships as well. Roketsan have a Spurge system which has rockets and Gatling guns in the same platform. We have everything in Turkey. There are many options, but the question is, of course, money and funds. I don't have the money. We can have one quick last final question, please, very quickly. Esteemed directors, first of all, I would like to thank you all for the projects that you are working on. As youngsters, I want an advice towards us. What should the youngsters who love their nation should do? Let me answer if you like. Are you a university student? Yes. Which grade are you? I'm one. I just started. Are you studying engineering? No, I'm studying air. Techniques. And what I suggest to every youngster is Turkey. What we need to realize is Turkey is in competition. We have great technology now, but to achieve sustainability for that, our youngsters should be able to help with that. It's not just about theoretical education or university education. In Technofests or TÜBİTAK competitions, international competitions and events, you have to represent our country both in theory and in practice. We want them to develop themselves, so we continue forward. And my biggest advice is don't do it alone. Always establish a team, because technology is reaching such a point that it's not a one-man game anymore. You need a group. So you need to develop your group working skills, and it will allow you to have success better than anything else. So teamwork, combining practical approaches with theory, and getting ready for international competition, getting the know-how and knowledge base required for that. So I believe a strong youth like that is going to bring us to higher greatness. All right. If we don't have any additional remarks from our panelists, we would like to thank you all for being with us and listening to us. I believe it should be a great rest of the day in this expo. Thank you. Thank you very much to our esteemed moderator and panelists for the memory of today. We would like to present them with a gift. Dr. Sayın Aykan Tuşpınar, retired general, is going to present them with their gifts. Then we will have a photograph taken of our panel.